morning, everyone. Today we'll be learning about noble gas electron configuration. Noble gas electron configuration. As the name says, noble gas, in the electron configuration, we will be including these symbols of the noble gases. And noble gases would be group number 18. We know that the periodic table has 18 groups or 18 columns and 7 periods, which would represent the period number, would represent the principal energy level for us, and the groups would be representing sublevels for us. Okay, so if we look closely, group 1 and group 2 together would be S block elements because the electron configuration ends in S sublevel. Group 3 to group 12 would be D block elements because their electron configuration ends in D sublevel, and group 3 to group 18, with an exception of helium, would be p block elements because their electron configuration ends in p sublevel. And then we have these lanthanides and actinides where the electron configuration ends in F sublevel and therefore known as F block elements. So now we have divided the periodic table based on electron configuration. Groups 1 and 2 are known as S block elements. Groups 3 through 12 are known as D block elements. Group 13 through 18, with an exception of helium, are known as P block elements. And the lanthanides and actinides, the inner transition metals, are known as F block elements. Let's look at these blocks a little closely. So we'll start with the S block. S block group 1 elements, they all end in S1 configuration. Group 2 block elements, group 2, all of these elements, the electron configuration for all of them ends with S2. And let's move to P block now. P block, group 13, the electron configuration for all elements in group 13 ends with P1. For group 14, it ends with P2. Group 15 ends with P3, Group 16 would be P4, and Group 17 would be P5, with an exception of helium. All of the elements for Group 18 would end with P6. Okay. Now let's look at this D block elements. The D block Group 3, they would end with D1, D2, D3, D4, D5, D6, D7, D8, D9, and D10. And these F block would be F1, F2, F3, F4 through 14. So now let's look at this exception. We learned that group 6 ends with S1, D5. So we're going to write that. And group 11, electron configuration ends with S1, D10. Okay. There is one more thing that we need to know for the periodic table is that when we start filling the D block, so we start filling the D block here, it would be the energy level would be 1 less than the actual principal energy level. So this period here is period number 4, but the D block would be 1 less. That means n minus 1 always. So this row here would be 3D, and this would be 4D, 5D, and 6D. Let's start with an example. Oxygen, which has 8 protons and 8 electrons, and oxygen is over here. Okay, for noble gas configuration, we need to look at the elements placement on the periodic table and then try to find the noble gas that comes before that element. And for oxygen, the noble gas that comes before that element is helium. And therefore, we will write helium symbol in brackets like this. And after helium, we start with period 2, that means energy level 2, and the sublevel would be S. And we know that there are 2 electrons in the sublevel S. After that, we move on to the second energy level, sublevel P, and we know that oxygen is in P4. This is P4. The number of electrons in the sublevel P would be 4. 1, 2, 3, and 4. This here is the noble gas configuration for oxygen. So let's look at a different example now. Okay, and uh, let's choose arsenic. Arsenic has 33 protons and 33 electrons, and arsenic is over here on the periodic table. Okay, the noble gas configuration for arsenic would be like this. We have to look at the noble gas that comes before arsenic. The noble gas that comes before arsenic is argon, and so we're going to write the symbol of argon and put brackets like this around it. This represents electron configuration of argon. And after argon, we start with period 4. That is means energy level 4, sublevel S, and there are 2 electrons. And from here, so we are up to this point, we have to reach to arsenic. So that means we have to go through these electrons. And now we need to fill in 3D. After 4s comes 3D. And we know that there are 10 electrons that it can accommodate. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now we are here. We are up till this point. After 3D, we start filling 4p. And arsenic has 1, 2, 3, P3. There are 3 electrons in arsenic. So this is the electron configuration for arsenic, noble gas electron configuration. So see how we have condensed it to this. Let's take another example, and this time we'll take zirconium as our example, which has atomic number 40, 40, zirconium, atomic number 40. Okay, and we're going to write the noble gas configuration. So this is a placement of zirconium on the periodic table. We'll start with a noble gas that comes before zirconium, and that would be krypton. So we're going to represent the electron configuration of krypton in brackets like this. And that would constitute all of the electrons that krypton has. So after krypton, we start with period number 5, which would be energy level 5, and we start with sublevel, and there are 2 electrons in it. And after 5s, we have 4d. So we'll fill 4d. Okay, and that would be D1 and D2. This is where zirconium is in this column with D2 electron configuration. So this here is the electron configuration for zirconium. See how we have condensed it. So noble gas configuration helps us condense the electron configuration this way. And again, periodic table is a cheat sheet, so we use the periodic table to write the electron configuration. Let's count the number of electrons in zirconium. Krypton has 36 electrons, and then there are 2 electrons in the 5s sublevel, and then 2 electrons in the 4d sublevel. Together, there are 40 electrons.